I'm here today with Robert Sungenis. Robert Sungenis is known for his apologetic work against Protestantism and also for his work about geocentrism. So, Robert, can you quickly tell our listeners what is geocentrism and does it have anything to do with this flat earth movement, which we see everywhere on the internet right now? Can you give us like a 1-minute introduction in the whole topic?
Sure. First of all, it has nothing to do, as far as I am concerned, with flat issues. Okay, they tried to commandeer me to their movement, and I said no, because even though you believe the Earth is in the center, you believe it's flat, and that's just. And I wrote a book against it, Flat Earth, Flat Wrong, that was published 2 years. So that was 700 pages that I wrote on the flat Earth issue. I actually was in a debate with the flat Earth people about 2 years ago as well. At any rate,
yeah.
So geocentrism is basically that the Earth is in the center of the universe. So geo is Earth, centrism is central. The Earth is. That would mean that the sun goes around the Earth and the stars go around the Earth every day on what they call the sidereal cycle. And the moon goes around the Earth, and basically that's all there is to it, is that the Earth is in the center of the universe. So you wanted a 1-minute summary, and there you have it.
So Germans are very, very skeptical people. So when I tell other German people that I don't believe in evolution, for example, they already think I'm really crazy. But if I would tell them that I believe that the Earth is the center of the universe and the sun and everything is going around the Earth, they probably will put me in a mental clinic or whatever. So maybe you can give a short apology for our listeners with modern scientific facts why you believe that the Earth is in the center, so that we don't lose all our listeners even in the first minute.
All right, well, let's jump right to Albert Einstein, because he's the crux of the whole issue. Albert Einstein was German, right? So yes. If you're German, then you should pay attention to what this German scientist said. And that's what I did when I wrote all my books and made my movies, is I listened to what Albert Einstein said. And in his general theory of relativity that he invented in 1915, he came to the point that he said, it's possible that the sun and the stars revolve around the Earth, with the Earth being in the center. It's also possible that the Earth rotates on its axis and it looks as if the sun and the stars are moving around us. And he said either one is possible, and that is because of the theory of relativity. Relativity basically says that everything is in motion. And so if we claim that the sun, well, from a relativistic perspective, we can change that around and say that it's the sun going around the Earth, just because of the nature of relativity. Okay, so that's what started the ball rolling on this whole thing, is that ever since relativity replaced Newton's physics, we have a whole new perspective on the universe than we did in Newton's day. In Newton's day, all we had basically was the solar system. And he made his equations, his famous equations, F equals ma, or F equals gmm over r squared for the gravitational equation. He made those assuming that all we had was the solar system, and the universe really was inert and had no effect on our little system here, our little solar system. That all changed 200 years after Newton, when Ernst Mach came along, another German, by the way. So we have Ernst Mach and Albert Einstein, two Germans, who basically said that Newton's system had flaws, and that was because he assumed that the universe had no effect on our little solar system. And they said, if you include the universe in all the equations, then you can come to the point where the relativistic nature of motion allows for the stars and the sun to revolve around the earth, or it will allow the earth to rotate within a fixed universe. Either one is possible according to general relativity. Okay, so if that doesn't move your German people, I don't know what will, but that's where it all starts right there.
Okay, so can I understand it a little bit like when I sit in a train and the train next to me is starting to go, then I don't know if my train is going or if this train is going. Is it something like this relativity?
Yeah, as far as observation goes, you're exactly correct. But it even goes deeper than that, because you know that when your train moves, you feel inertial forces. In other words, when your train goes forward, it pushes you back. Okay? So you know that when you feel those inertial forces, that your train is moving and the other one's standing still. Okay? Let's say that you can't feel the inertial forces and you see the train next to you in relative motion. Okay? Then what do you conclude? Well, you don't really know. You don't really know if you're the one who's moving because you can't feel inside your train. And so you might say, well, the other train is moving because I can't feel any forces, but you still don't know for sure. Okay. So, and this was the issue with Newton as opposed to Ernst Mach and Albert Einstein, was Newton's equation said force equals mass times acceleration, okay? But he didn't have any inertial forces. He had to add those in there by hand, and that was his flaw. When Einstein and Mach came along, they said, look, the inertial forces of one system can correspond to the gravitational forces of the other system. What that means is this: you can run the universe by gravity, or you can run it by inertial forces. And I'm talking about the centrifugal, Coriolis, and the Euler forces, okay? And if you do that, okay, that means when the universe rotates, it has angular momentum, and that angular momentum causes those inertial forces, centrifugal, Coriolis, and Euler forces. And they act as gravity, okay? And that's why that system will work, because those inertial forces will hold all those stars as the universe rotates in their positions so they can't move, and they will all rotate around a centralized Earth, okay? Or you can have the system where you have Earth that's controlled by gravity, and the inertial forces don't really matter that much. And so you can have the Earth rotating and revolving around the sun, and everything will work by gravity, like Newton said, you see. So we didn't know all this stuff. In other words, we didn't know the relationship between gravity and inertial forces until Ernst Mach and Albert Einstein came along, which was a long time, you see. But because of that relationship, the geocentric system works. It's scientifically valid, in other words.
Okay. So we Germans, we are not only skeptical, we are also very into authority. If an authority says something, then we are likely to believe it. So when I talk to my German friends and say, talk to them about this geocentrism thing I discovered in your videos, then they will immediately say, okay, maybe it's interesting and whatever, but how can it be that the scientific community totally rejects it and it seems to them like a conspiracy? How can the whole scientific community go basically against this idea? how can you explain it that they are all fixed on heliocentrism?
Okay, well, that'll take a little bit of time because we have to go into the history. But you have to understand that the Catholic Church was basically in control of society for a very long time and didn't lose that control up until, let's say, the High Renaissance, the Reformation, and the Enlightenment period. The Church's authority over the people was waning at that time. And then when you get to the modern age, the Church's authority is just over the Catholic people. It's not over the world anymore, okay? That's important to know because the cosmological, cosmogonical system that the Catholic Church accepted was the one of Ptolemy, the geocentric one. And he was a Greek philosopher in the 1st century AD. And he developed a system that put the earth in the center and everything revolving around it. And the church really had no reason to change that at all because it worked pretty well, actually. And nobody really had access to telescopes or things of that nature to go and examine. All they could do is look with their eye at the sky and make their calculations. And that's basically what Ptolemy did. The Greeks had done that before him, but the Greeks were divided. The Pythagorean school, they were all heliocentrists, but the Aristotelian school were all geocentrists, okay? And they knew a little bit about relative motion back then. They knew that both systems could be made to work. But the Catholic Church chose the geocentric system, and the reason for that was that Scripture teaches the geocentric system. Of the two, the Scriptures say that the sun revolves around the earth, not the earth around the sun, okay? It says it probably, say, at least a dozen or 24 times, okay? So the Catholic Church took Scripture literally, and so thus the geocentric system became the dominant system, and there was really no competition. Then when Copernicus came along in the 1500s, he was reading the Greek philosophers, Aristarchus, who was from the Pythagorean school, and Aristarchus was teaching heliocentrism. And for some reason, Copernicus was enamored with the Greeks, and basically he took Aristarchus's system, the geocentric system, the heliocentric system, and put a few bells and whistles on it in his book and published it in 1543. So now we had competition. The church had competition now. For the first time, someone was proposing that there's a different cosmological system than the geocentric one. And Copernicus's book, when he published it in 1543, was immediately condemned by the Catholic Church. And about 20 years later, the Index of Forbidden Books. So we had a battle going on. Now, about 75 years later, Galileo comes along, and he starts promoting the Copernican system, heliocentric system. And the church says, okay, you know, we have to deal with this officially now. We had condemned Copernicus's book, but this thing keeps cropping up because there was a priest before Galileo that actually had started the ball. That was Father Foscarini, and his book was condemned. He wrote a book on heliocentrism, the church condemned it. And then the next year, Galileo came along, and he wrote 2 letters, one to a region of Tuscany. Her name was Christine of Lorraine. And he wrote to her and said, oh, it's perfectly okay to believe in heliocentrism. Even the Bible can support it and all this. So when he said the Bible can support heliocentrism, that's when the church got involved. Because now, since Scripture was the authority for your interpretation of the cosmos, and you're saying that Scripture teaches something opposite than what the Catholic Church has taught, well, now there's going to be a battle. And so Galileo was brought before the Pope and Cardinal Bellarmine, and he was told, look, this is a formal heresy. We don't want you to teach it. We don't want you to think about it. We don't want you to speak about it. We're right about it, okay? So that was a dividing line that the Catholic Church had put in place. And so the story I'm trying to build here is one of authority. Who was in control? Well, was the Catholic Church in control? The Reformation period had just started, but Calvin and Luther were the opposition to the church in the issue of Galileo, because they were actually believing what the church had said, the Catholic Church. But after the church dealt with Galileo and condemned his books in both 1616 and 1633, by the time of around 1680s, Newton came along, okay? And this was really the breaking point. When Newton, you see, everybody before Newton was just looking at the geometry. You know, Tycho Brahe or Galileo, Copernicus, Kepler, they were just looking at the geometry of the solar system to see if they could make the Earth the center or the sun the center. And so they would battle back and forth, because the geometry, basically, as long as you keep all the distances the same, you can make anything the center and make it work, you see. The question that now came up with Newton was, well, you can make the geometry work, but can you make it work dynamically? And what he meant by that was, can you show us what the forces are that are making these things move as you claim they move? If you claim the planets are moving around the sun, tell us what the forces are that are pushing these planets around the sun. Or if you think the sun is going around the Earth, well, then show us the forces that make the sun go around the Earth. So that was the big question. And he was working with Euler, with Leibniz, with several other people on the physics of the solar system here. So what he did, as I said before, is he confined the system to the solar system. And in that system, if you use just that system and you disregard the rest of the universe, his equations work, because the sun is more massive than the Earth. And so it has to be the center of mass for the solar system. And that means that the Earth has to go around the sun. And so does Mars and Saturn and Jupiter and Uranus and Neptune and Pluto and Mercury, because they're all smaller than the sun, you see. So this was very persuasive, very persuasive. I mean, Immanuel Kant got behind Newton and said he was the genius, and finally figured out how the cosmos worked, because he used mathematical equations that dealt with force. And that's what F equals ma is, his most famous equation. Force equals mass times acceleration. And if you use that formula, then it determines that the Earth has to go around the sun. There's no ands, ifs, or buts about that. That has to be the case, okay? So basically, Newton was the one who turned a whole world toward heliocentrism. I mean, if you have Immanuel Kant behind you and all the philosophers, there's really no contest anymore. It's over, you know? And so anybody who still believed in geocentrism was considered a quack, primitive, you know, just going by church authority and not by science, because science was the one that brought in all this issue about forces. And boy, it had a great argument, you know? I mean, if I lived in Newton's day and wasn't privy to this information that I got from Mach and Einstein, I'd probably be a heliocentrist too, and call all the geocentrists quacks. So that reigned for 200 years. You see, from the time of Newton around 1684, when he published his famous book, the Principia, until Mach came along in the 1880s, that's 200 years. So you had 200 years of heliocentrism without anybody contesting it, basically. There were a few people here and there, but that was it. And so when you're talking about authority, that authority has shifted pretty well from the Catholic Church to Isaac Newton in the late 1600s, and wouldn't change again until the late 1800s when Mach and Einstein came along.
But they are already like 100 years ago again. So why is the scientific community so united, you know? For example, for the evolution topic, at least we have the Christian scientists, but like when I became a evangelical Protestant, true Bible-believing Christian who actually takes the Bible serious, I learned very quickly that there are Christians who defend, for example, the creation against evolution. But I've never, even in this Protestant fundamentalist community, I've never seen anyone who defends geocentrism except you. So how does it happen that even in the Christian community of scientists that nobody believes this, that it has no lobby, you know?
Well, the Christian, you know, we're early in the movement, number one. Okay, it takes hundreds of years to make something stick, scientifically speaking, especially when the science of your day is so one-sided. Okay, that's number one. Number two is the Christians get their science from the secular scientists, unless these Christians become scientists themselves. But here's a bigger issue. The issue is, if you admit to geocentrism, even if you are a Einsteinian PhD in general relativity, and you know that the two systems are viable, geocentrism and heliocentrism, just from the physics, what are you going to do? If you have a choice to believe in one or the other, which one are you going to choose? Well, you're going to choose the heliocentric system, because that's what all your colleagues have done. And why have they done it? Well, because if you choose the geocentric system, that means you just gave credibility to the Catholic Church. That means the Catholic Church was led by the Holy Spirit to give us this geocentric system and condemn Galileo. So if you take the modern science and you agree with the Catholic Church, the game's over, because the Catholic Church was the first one that said heliocentrism was not correct and geocentrism was, and we're going to stick with it because Scripture told us, you see. So any scientist today who gives any hint that he's leaning toward geocentrism, well, then he's giving the authority back to the Catholic Church. And that's exactly what they don't want to do, you see. This now becomes a theological football where those who believe in heliocentrism can maintain their distance from the Catholic Church and not regard the Catholic Church as the authority. And that's why they do it. Theologically speaking, that's why they do it, you see. Whether it's Protestants won't touch geocentrism. Why? Because if they believe in it, they're going to give credibility to the Catholic Church. The Catholic Church was the one who can do it.
On the other hand, the Protestants only go by the Bible. So you said that geocentrism is supported by the Bible, and nowadays we even see the Protestant believing in like a flat Earth stuff because they believe it's in the Bible. So shouldn't there be?
Well, the flat earthers believe that the flat earthers believe that the Earth is in the center. Okay, so they're trying to take the Bible as literally as possible. The other Protestants, like say the ones for Creation Research Institute, or there's a couple of them out there, and I know them, Danny Faulkner and all those guys, they only will take the Bible literally to a certain point. When the Bible starts talking about geocentrism, these same guys who took it literally for creationism over evolution will not take it literally when it's a subject of geocentrism versus heliocentrism. They've drawn the line, you see, and that's all psychological, because they know that if they agree that the world is geocentric, well, then why did you split from the Catholic Church in the first place? If the Catholic Church is right about even this issue and had the authority to condemn Galileo, well, that means you're basically condemning yourself if you agree that the Catholic Church's geocentrism is correct. And so there's a lot of psychology that goes on this. The more that they avoid the issue or stick to heliocentrism, the more they distance themselves from the Catholic Church.
Okay. Can you give our listeners one example, one very good example from the Bible where it's clear that it talks about geocentrism and not in a relativistic way, you know, with the two trains? So that you cannot say, oh, it's just anthropomorphic speaking from the view
Right.
of us humans, how we perceive it. You know, can you give an example
I
where
will
it's
do
clear
that.
that it must be geocentrism?
Right. I will do that in a second after I give you the introduction. The passage I'm going to go to when I deal with it is Joshua 10, which is the same passage that Cardinal Bellarmine used against Galileo. You can't get out of that one, okay? The other passages where it says in the Bible, the sun rose or the sun set, things like that. Those are what we call phenomenological. That is, we see the sun rising above the horizon or we see it setting into the horizon. So whether you're a geocentrist or a heliocentrist, you're going to say, oh, the sun's rising or the sun's setting. Now you both know that the sun's not really rising or setting, okay? The heliocentrist believes it's the earth rotating on its axis that makes it look like the sun is rising or setting. The geocentrist says, well, the sun's going around the earth and that's what makes it look like the sun is rising and setting, okay? But you're both using phenomenological language when you say the sun sets or the sun rises, okay? So I just wanted to make that clear to people so that they don't say, oh, well, all these passages are metaphorical or they're, you know, what do they call them? Sight on scene passages where it looks like this is the case, but we know scientifically it's not. Well, the geocentrist also knows scientifically the sun isn't rising either. So you can't use those passages against the geocentrist because he looks at them phenomenologically also, okay? Now, what we do know for a fact is that there is a cause to why we see the sun rising and setting. The question is, what is the cause? Is it because the earth is rotating or because the sun is moving around the earth? Okay, two very viable explanations to the same phenomenological issue. Which one's correct? Well, when it comes to the Bible says the earth rotating is not the answer. The sun moving is the answer, okay? That's how the argument starts. Well, where is that in the Bible? Well, then we go to Joshua 10, okay? Now in Joshua 10, you have an instance where the Israelite armies are fighting 5 different armies from the pagan nations. And Joshua, who's the leader, is on top of a mountain, and these 5 armies are trying to come up the mountain to get the Israelite army. And the sun is in the skies at 12 o'clock, and it's beating down on the pagan soldiers that are trying to come up the mountain. And this is a military tactic. Whoever has the highest point is usually going to be the victor, because the other ones have to put up with the glare of the sun in their eyes. And it's very hard to fight if the sun is in your eyes, okay? Especially if your enemy is up on top of the mountain. So this is working so well for Joshua, and he has 5 armies to defeat, that he calls upon God and says, can you make the sun stay in the sky for an extra day while I defeat these armies? Because I have a military advantage, basically, because the sun's glaring in their eyes. And God says, yes, we'll make the sun stay there for a whole day. And so that's what happens. The sun stays in the sky for 24 more hours at 12 noon, okay? Now, the other thing that happened is it says, and the moon will stay still in the sky over the valley of Gibeah, okay? So what happened was the sun's at 90 degrees, and then the moon is over here in Gibeah, let's say about 60 degrees, okay? And they're both standing still in the sky for one day, all right? So if somebody tries to explain this by saying, well, if it happened physically, that means that the earth could have stopped rotating, okay? So that's what a heliocentrist would say to try to explain this passage. But he can't. And the reason he can't is because of the moon. The moon moves independently of both of the universe and the sun. The stars, you have the sun, and you have the moon. And the moon actually goes faster than the sun does, okay? So if the Earth had stopped rotating so that the sun would stay in the sky, you still have to deal with the moon. In about 5 hours, the moon would go into the Mediterranean Sea, dip into the Mediterranean Sea. If you had stopped the Earth from rotating, the moon would keep moving. But the point of fact is that the moon stayed in the sky at 60-degree angle from where Joshua was, and the sun stayed at the 90-degree angle and didn't move for 24 hours. That means that the moving bodies had to be the moon and the sun, and both of those bodies had to be stopped. Okay, that was the argument that Bellarmine gave to Galileo.
But could one not just say that God just paused the whole universe, basically, to not mess up anything, and that's why the moon also was standing still?
Exactly. That's exactly what I'm saying. The whole stars, sun, and moon stopped. It just doesn't have the stars included in the story.
But I mean,
but if he stopped the universe, that means the universe was rotating. You see?
What I mean is that God stopped the Earth and the moon and everything, basically. So nothing is moving anymore.
But you don't have to. You can only have one. You can't stop the Earth and the moon and the sun, okay? Because all you would need to do is stop the moon and the sun if the Earth was standing still. If the Earth was rotating, all you'd have to do is stop the Earth. But then, as I said, the moon's going to keep moving.
What if God stopped the Earth and the moon to not mess up anything, just pausing everything, you know? For also maybe stopping other galaxies and everything, just stopping everything, you know? Could this not be an explanation?
Well, I think you're reading more into the passage that it allows, okay?
Okay.
Because the passage says that God stopped the sun and the moon. It doesn't say anything about the Earth being stopped. So God doesn't have to come in there and stop the Earth, the moon, and the sun because the Earth is already stopped. The Earth is not moving.
Mm-hmm.
That's the very reason that he has to stop the sun and the moon from moving, because the Earth isn't moving.
Okay. But it doesn't say anything about the stars, does it?
Well, no, because we're just dealing with the sunlight from the sun. We don't need the stars involved. You can't see the stars anyway in the daytime.
But in the geocentric model, the whole universe must be stopped. So also the stars and everything, right?
Yeah, I mean, that probably happened, okay, to keep everything fixed in its positions. But there's no need to bring that into the story. It's just an irrelevant fact. But the fact, as you said, would be true, that the stars would be stopped as well. They just don't have any relevance for the story.
I'm just saying it because if God mentions already two bodies, the moon and the sun, why not mentioning also the stars, you know? But you're right, basically, for any view, it's just too far away. They don't even matter.
Yeah, I mean, they're just irrelevant. I mean, it's just not an issue.
Okay. So how did you get aware of the whole geocentric issue?
About 2003, I had nothing to do on one Sunday afternoon, so I was just searching around on my internet, and I ran into a PhD in astronomy who was saying that the Earth was in the center of the universe and wasn't moving. And so I had to make a decision on that day whether I was going to press the next key and go into his website, or I was going to go outside and play basketball. I was a little tired that day, so I decided to press the key to get into his website, and that was it. I mean, I started to read his material, and I was a physics major in college for a while, and so I knew the physics behind this, what he was saying, and it all made sense to me. And it's the first time I had ever seen it. I had no intention of being a geocentrist, okay? I just happened to read this material. I was enamored by it because he made scientific sense, okay? And then as a Catholic apologist, however, I saw the importance of this issue, because the Catholic Church has gotten beat up so bad because everybody thinks they made the wrong decision about Galileo. Well, what if they made the right decision? What if this guy is correct that the earth is in the center and isn't moving? That means all this abuse that's been put on the Catholic Church for centuries as some primitive organization that knows nothing about science is all, it's wrong. And so that put me on the quest to say, look, if this guy is saying the truth, then this changes everything. This means that the church was right about Galileo just as she's right about every other dogma that we believe. And the Holy Spirit wasn't taking a vacation when the church was dealing with Galileo. Okay. So
yeah,
that moved me on.
If the earth is in the center, it's quite an argument for the intelligent design theory, that if it's in the center, that's a small chance, So
small. I mean, absolutely
obvious that it's placed in the center if it's in the center.
Yeah, I mean, that's been my argument since I started, was that if you're Carl Sagan and you want to get away from the idea of God creating the earth as much as you can, what are you going to propose? Well, you're going to propose that the earth is out there in the remote recesses of space, tucked in some corner of the universe that we have no idea where it is. We just know it's out there somewhere and just came by time and chance. And it's going to be here one day and gone the next, just like we are. And there's no rhyme or reason to my life. And therefore, I don't have to answer to a God when I die, who's going to say to me, have you worshiped me? What works have you done so that I can save or damn you? That's the last thing these guys want to confront, okay? Because they know that if the earth is in the center of the universe, that means someone with a capital S put it there, because it's not going to happen by time and chance, you see? So as soon as you start talking geocentrism to them, they know what you're talking about. They know that you're saying that God exists and he's going to be my judge. And they don't like that. And so that's why all these scientists are atheists. Heliocentrism and the Big Bang support all their atheism. And they're comfortable with that. And that's why geocentrism is anathema to them.
So it's basically like if we turn back the time, if we catch evolution, the people must become theists again. And if we also take away this heliocentric perspective, then they must even become Catholics, not only Protestants, but Catholics.
Exactly right. That's what I was saying about with the 10-foot pole, because they're going to have to become Catholic. I mean, if the Catholic Church is not in error on Galileo, she's not in error on anything, which means your whole Protestant Reformation was wrong, okay? They don't want to go in that direction, so they keep fighting it. If you're Stephen Hawking or Albert Einstein or whoever, you're not, even though your theory says that you can allow the earth to be the center of the universe, you're not going to want to go there, because that smacks too much of God, you see. And there you go. I mean, that's why they fight me tooth and nail.
You are a very special apologist, and I mean this in a very good sense, because you don't back up even 1 millimeter. Usually what I experience, especially in Germany, is that the church is like defending and moving backwards and says, it wasn't like this with Galileo, they relativize everything, and basically they admit their error. So what would you say? Didn't the church already admit that it was wrong? At least this is the impression we get in Germany, that the church admits it's wrong about everything, Galileo and evolution and whatever. That's what we learn.
Well, this just tells you how big this issue of geocentrism is. If you had to point to one time in history where the church lost its authority over the world, it would be geocentrism, because that came before evolution. So once the church gave in and said, oh, well, we were wrong about Galileo, well, what does that do in the mind of the scientists? in the mind of a scientist, that means, oh, well, that means the church is wrong about evolution. The church is wrong about genetics. The church is wrong about paleontology. The church is wrong. All kinds of things that geocentrism now opens the floodgates for all these scientists to believe in opposition to the Catholic Church. So science now becomes the king, at least the science they want to believe in. And if there's any chance that the scientist or that the science supports geocentrism, they just tuck that away. You say, we'll just pretend it's not there, is what they do. But the church, because she hasn't really been exposed to the other side of the story, that is that geocentrism can be supported scientifically, because they won't even talk to me, okay? So when I say that the church's stance against Galileo can be supported scientifically, they look at me like I'm crazy. And so they think that if the church made an error with Galileo, then the church is continually going to make errors as we go down the road. And that's why your German bishops and priests retreat. They're all starting from this Galileo issue that, well, if we were wrong about Galileo, what else are we wrong about? Is basically what they come to the church with, you see.
But that's why I have you on today, so that we can hear both sides of the story.
Yeah. If you can get them to listen, that's the key. You see, if you can get them to listen to you.
I'm working to get my YouTube channel bigger, so maybe one day. I have some priests who are watching my YouTube channel, I know that. But also for the lay people in general, for everyone, even for atheists.
Yeah.
I think it's a very important topic.
One thing that is an obstacle is the science is a little difficult for people. You know, they haven't really been taught science. They may have had a high school chemistry class or something, but that's about it. Physics is hard. And even when I was in physics as a physics major in college for a while, at least a couple years, it was hard. I did well, but it was hard for a lot of people. But even me, with my physics background, I had a hard time understanding how to put all these things together. And here I am, 2020, so that's 17 years down the road. And I'm finally getting all the dots connected and see how everything works, where I can go out there and with very much confidence give the geocentric side of the story. But it took me a long time to get there. And I think that's what intimidates a lot of people, is they see, you know, these big math equations and, you know, talking in relativistic terms and the speed of light and all this stuff, and they get intimidated by it, and so they don't go into the science. But there are other people out there that are very smart, and they're Catholics, and they know that if they get into this, they might be turned into a geocentrist, and so they avoid it like the plague, you see.
Okay.
So
yeah, that's true. Actually, the most people don't know the science. Although the same for evolution. I don't know the science as much either, you know. I'm not a science guy, but the most people aren't. Like maybe they had a college course if they're lucky, but in fact, the last time people heard about biology is like in high school, or what in Germany would be high school, you know. So most people have no idea anyway. But I think this relativity principle everybody can understand. In the end, same if like with a train, if this train is going or my train is going, it looks the same. So
yeah.
in the
Matter of fact, I use that train example in my book, my new book, Geocentrism for Dumpskis. I use the train example.
Okay. Yeah, but can you give us like modern evidence, for example, the axis of evil, which proves geocentrism? Because if we have only the relativity, it's like both can be right, and why not be a heliocentrist then? So can you give us modern discoveries which totally destroy this heliocentric worldview?
Yeah, well, this is what our movie, The Principle, was all about. Was about the axis of evil that you just mentioned, the cosmic microwave radiation that causes the acts of evil. And but there's a story behind that you need to know, and in order to see how important
Explain
this
us.
really is. And I will. It starts with Edwin Hubble back in the 1920s. And Hubble was the man who basically gave us the Big Bang Theory. Okay. And this is how it happened. He's looking through these giant telescopes out there in California, Mount Wilson Telescope, the Mount Palomar Telescope. These are gigantic telescopes that can see really far into the universe. And we see galaxies for the first time in human history. You look through the Mount Palomar Telescope, you see galaxies like all over the place. And as Hubble began to investigate the evidence of these galaxies, he did spectrum analysis on them. And he saw that the light from all of the galaxies, wherever he looked in the universe, north, south, east, west, wherever, he saw they all had one distinguishing characteristic. And that was that the spectrum analysis revealed that the light was shifted to the red end of the spectrum, not the blue end. And in light physics, that means that something is affecting the wavelength of the light so that it gets longer, the wavelength gets longer so that it shifts to the red end of the spectrum, okay? Now, as an astronomer, he's looking at all this and he says to himself, well, if I see redshifts everywhere I look, what does that mean for us? Well, that means the Earth is in the center of it all. Because if the Earth wasn't in the center, then he should see blue shifts at various points in the universe when he looks. But he didn't. He only saw red shifts, and he knew this was a problem. And he says in his book, in 1937, he wrote about this, and he says, this is intolerable. This is not acceptable. This is, I mean, he goes on and on for pages saying, how we can't accept the Earth in the center of the universe because this destroys all our theories, you see. So he has to figure out, how do we get out of this problem? Because Copernicus said the Earth is not in the center, and, that's what we're going by, and that's what we're going to stick to. And so he comes up with this ingenious idea that, all right, what we'll do is we'll take the center out and we'll turn the universe into a balloon. Now, a balloon just has a surface. It has no center. Yeah. There's just air in there. There's no point you can call the center, unless it's imaginary, but you put the whole universe into a balloon, and then you put the galaxies on the surface of that balloon, and then you say that the balloon is expanding. And because one galaxy is getting farther from the other galaxy, he's going to see a redshift in his light coming from that galaxy. And if this galaxy over here sees it, he's going to see a redshift. So every galaxy, because they're all spreading apart, are going to see redshifts. And so that's how he explains the redshift. Now, what does that do? Well, that gets him out of having the Earth in the center, because that's the other way that you would explain how to see shifts. Okay? So that's important, because people need to know where this idea of an expanding universe came from. It came from somebody who didn't want to put the Earth in the center. Okay? And so now the question was, okay, if the universe is expanding, that means at one point it was a lot smaller until you get down to this little p, whatever they want to call it, where the explosion started to make it start expanding. Okay. Well, when Hubble figured that out, he could only come up with 1.5 billion years in his little formula, no matter how hard he tried. When the thing started, it was 1.5 billion years, but that was a problem, of course, because why? Because evolution said that the Earth was already 4.5 billion years old. And the universe itself was 8 billion years older than that. So how could you have only 1.5 billion years? So they kept twisting Hubble's numbers, and they made it used to be 10 to 20 million. Now they settled on 13.78 billion as the years of the expansion. But they already started to fudge figures on this, okay? So now we're going to get to the cosmic microwave radiation. In 1963, two U.S. scientists, Penzias and Wilson, discovered this microwave radiation that was very small, hardly detected, and they actually fell into it by accident when they saw it. It was 2.75 degrees Kelvin. Okay, any energy you can put a temperature on. This was one of the lowest temperatures that was found, and 2.75, and everybody was so happy because they said, oh, we know what this is. This is the remnants of the Big Bang, you see. And they were using Hubble's expansion because they figured, well, when the universe blew up and expanded, there had to be all this radiation, and that was 3,000 degrees Kelvin. And by the time you get to the end where we are now, that 3,000 degrees Kelvin became 2.75 degrees Kelvin. And that's what we see out there, all this microwave radiation, okay? So they were celebrating and getting all happy and everything. And until 1978, they did, this 15 years later, they sent up probes to do some studies of this microwave radiation. And they began to see something very mysterious. And that was that the radiation was not smooth, at least not as smooth as they expected it to be. In other words, there were lumps of higher radiation over here, lower radiation here, higher down here. And so the universe was lumpy as far as the energy was concerned. And that was a concern, because if you're going to declare that there's a Big Bang, okay, that bang, or the energy in that bang is going to have to go out, what they say, homogeneously and isotropically. That is, it's going to be very smooth. It's going to be the same wherever you look, you see. That's called homogeneous.
But can it not be that the gravitation slowly makes these dots? You know that?
Yeah. So there is a little bit of what they call anisotropy there as it starts clumping together. But we're talking about radiation. Radiation doesn't clump together.
Oh, okay.
Okay.
Yeah,
radiation is supposed to be smooth. Okay. So they send up these probes. They find out that it's not smooth, and they don't know how to explain it. So then they sent up another probe in 1990 called the COBE probe, and they put this satellite 500 miles above the Earth to examine all the radiation that was around the Earth, and they came out with the same problem. Whenever they got the maps back, they saw this lumpiness everywhere in this radiation. And so 11 years later, they sent up another probe because they couldn't believe the first one, you see. They figured, man, maybe something went wrong. We got some mixed data in there, whatever. So in 2001, they sent up the Wilkinson microwave anisotropy probe, and it came back with the same thing, even worse, because it was much more accurate than the original COBE probe of 1990. And so they started analyzing this data, and by the time they got to 2004, this is when President Bush was going into Iraq, and he said there was an axis of evil between North Korea, Iraq, Iran, I forget what the other country was, but this was the axis of evil in 2004, militarily speaking. And so two scientists said, oh, we see this axis that's going right from one end of the universe to the other, and it's going right through the Earth, that's determined by this lumpiness of this radiation that we see. Oh, so we'll call it the axis of evil.
Okay.
You know, they're taking off on Bush's term, basically.
So why does it going directly through the Earth? What is the relevance of it?
Yeah.
Can you tell our listeners?
If, let's say the Earth is geocentric, okay, it's not moving. The ecliptic is at 23.5 degrees. That's a line that goes right through the Earth, 23.5 degrees, as opposed to the equator, which is at 0 degrees, okay? So this axis of evil is a direction that goes from one end of the universe in the southwest all the way up through the Earth's ecliptic and to the other side of the universe, northeast, right through the ecliptic, okay? So the question is, what in the world is happening if the Earth, what does that mean if the Earth is in the center of this microwave radiation that's expanded all over the universe? It can only mean one thing, that the Earth is in the center of the universe. Okay.
That's why they coined it axis of evil, because it's so evil to their worldview.
That's right. Exactly
Okay.
right. Okay. So they couldn't believe their eyes. And they wrote papers about this. University of Michigan, we had University of Arizona, all writing papers about this to see if there's some flaw in this data.
Yeah.
And they examined
That's what they have to do now.
Yeah, that's right.
So
they came out with a paper.
If I invent an apology for this, then I will be the next Nobel Prize winner in physics, right?
That's right. That's right. Now, let me tell you why it's probably not going to happen. Because, so after the Wilkinson probe, started writing the papers, and they found no flaw in the data. It's accurate. And so they said, look, we need to send up another probe. And so they called it the Planck probe, and they sent that up in 2009, 8 years later. And the data came back to them in 2013, and guess what? It was the same exact data that the other two probes had shown them 20 years ago.
Okay.
The axis of evil is still there, and so it won't go away.
It's still an issue in science right now, so they don't have any explanation for it.
Right, and that's after 20 years. Well, actually, that's at 7 years. It's 27 years now. They have no explanation for it. Okay.
Okay.
So basically, this just disrupts the whole Big Bang Theory. Okay. Not only does it disrupt the whole Big Bang Theory, it puts the Earth in the center of the universe.
Okay, but this reminds me of a story our ethnology teacher in seminary told us. There was a tribe somewhere, and they watched the horizon, and the horizon was always the same distance. Doesn't matter where they look, it's always the same distance. So they figured they are in the center of their flat Earth. So could it not be that this axis of evil is just, again, a perspective thing? So that, of course, when we look from the Earth, it might look that we are in the center of something, but we are not. Is there not maybe a possibility they come up with soon? Like I said, an apology, which brings a Nobel Prize, that they invent something new, like the Hubble guy did, that he said, oh, we are on a balloon, so maybe now they invent something else to say, okay, only it appears from Earth that we are in the middle, but it has some different explanation. Could this happen somehow?
What they tried to do along those lines that you're thinking is to see if they could make the galaxy the focal point of the axis of evil. Okay, and so they did these studies, and they found out that no, we can't make it go far out to the galaxy, because all the radiation is confined to this one direction where it's going through the ecliptic. And then what they did is they refined the analysis of the microwave radiation. They put it in quadrupole, octupole, 2 times octupole, 4 times octupole. What all that means is they kept refining the data so that they could see if there was any other alternative to what they were seeing it going right through the Earth. And as a matter of fact, what happened, the more they refined the data and tried to make it more specific, the more they found out that this axis of evil was going right through the ecliptic of the Earth. They just couldn't get away from it, okay? So don't believe me, somebody thought of your idea and tried to find another way out. The point is they couldn't find another way out.
It would already be very impressive if our sun would be in the center, or if our galaxy would be in the center. This would be very impressive already. But if you say it's our planet, then, wow.
Yeah. Well, we had one guy in our movie, John Hartnett. John Hartnett did studies on the galaxies. And he found that the galaxies are situated in concentric spheres around our galaxy. In other words, our galaxy is in the center, and then the other galaxies are concentric spheres 250 million light years apart. And there's 7 of these spheres. Okay, that's what he found, and he's in our movie telling us about it. Now, when I talked to John about this, I said, John, I said, look, if you're saying the galaxy is in the center and all the galaxies are surrounding our Milky Way galaxy, well, then why don't you just go the next step and say that the Earth is in the center of the universe? Why are you just confining it to the galaxy? Now, John Hartnett is a Protestant. He's a Protestant scientist. And he knows that if he says, well, yeah, the Earth is in the center of the universe, it's not just the galaxy, then he should become Catholic, you see. And he knows that I'm Catholic, and he knows my producer was Catholic, okay? But he doesn't want to go in that direction. So this is just further proof of what I was saying before.
Okay. I have a question. So let's say, so if we are in the center, if the Earth is in the center, and all the far away galaxies and stars rotating around the Earth once every 24 hours, wouldn't the outer ones be very fast, even faster than light?
Ah, good question. Now we come back to Albert Einstein, okay? When Albert Einstein invented the general theory of relativity in 1915, what did he have to say? He had to say that the speed of light is not constant any longer, okay? Now, why is that important? Well, because in the special relativity theory, 10 years earlier, in 1905, he said that the speed of light is always constant. And then when he came to general relativity, he said light can go any speed, and that speed is going to depend on the medium that it travels in, and the gravitational and inertial forces in that medium, okay? So the higher the gravitational forces and the greater the inertial forces, the greater the speed of light. So, all right, so in the 1915 theory of general relativity, Einstein admitted that the speed of light was not constant any longer. In the special theory of relativity, 1905, he claimed that the speed of light was constant. But that was an environment without gravity and inertial forces. When he had to include gravity and inertial forces in the 1950 general theory, then everything changed. Then he said, yes, light is not constant. It can go any speed, and so can any material object go any speed, okay? Because it's in a totally different environment. It's in a gravity inertial environment, and that means it can go any speed whatsoever, okay? So this would only make sense, because if the relative nature of motion forces Einstein to say that the Earth could be still and fixed and the universe has to rotate around it, well, he has to explain that by the forces, doesn't he? He just can't say that because we believe in relative motion, the universe is allowed to go around the Earth. He has to explain how that universe can go so fast, okay? And so the other part of his general relativity theory explains why it can go that fast. Because the further you get out from the Earth, the greater the gravitational and inertial forces. And that means the faster these objects can move and the faster light can move, you see. Now, you're not going to get this in Catholic high school or universities or even, you know, in graduate school. They're not going to tell you this stuff. You have to go in and read Einstein yourself in order to get this stuff. And that's why they hate me so much, because I go in there and get it out and I put it in the books.
So actually, it's a quite Protestant method. Ad fontes, go to the source of the matter.
That's right, exactly.
So the Protestants should really go into it. I have another question. So I can understand if for our solar system, if we say, okay, maybe the sun is not in the center, but still it works if all the planets go around the sun and they all go around the Earth, it's the same. I can understand.
Yeah, that's the Tychonic model.
Yeah, but for our galaxy, we are in a spiral arm, And it suggests to me, because of the design, that the whole galaxy goes around the center of the galaxy, and we are also just this one arm. So it suggests to me, the immediate impression is that we also go around the galaxy's center. But actually, the whole galaxy must go around the Earth. And so, like, this is the Earth, and this is an arm of the galaxy, and here's the center of the galaxy, and the whole thing goes around the Earth the whole time, and it looks like counterintuitive, you know?
Yeah. Well, let me explain a couple things. First of all, we don't know we live in a spiral galaxy. Okay? That's an assumption we make. Yeah. And the reason we make that assumption is because the nearest galaxy to us is Andromeda, which is a spiral galaxy. So we just assume, since we're in the same, but there's no cameras out there taking pictures of the Milky Way. The only cameras we have taking pictures of galaxies are the ones that take the picture of Andromeda, which is like 150 million light years away. Okay, so there's no proof we're in a spiral galaxy. But even if we were, what you're saying is correct. Okay, but we don't know if we are in a spiral galaxy. We don't know if we're on the spiral arm of the galaxy. That's only someone who comes along and says, well, since we're in the galaxy, we can't be in the center of the galaxy. We're going to have to be on one of the arms of the galaxy. Okay, because that makes sense to them. Even if that's true, okay, the universe itself is going to take that galaxy and move it around the center of mass of the galaxy. I mean, yeah, of the center of mass of the universe, okay? Because that universe and its inertial forces is so powerful, it's going to take everything with it. Think of a bowling ball, okay? And in the center of that bowling ball, you have like a simulation of the Milky Way galaxy. And the arm of that galaxy crosses right over the center of that bowling ball. Is that Milky Way going to have any power to resist it when you turn that bowling ball around and rotate it? No. Everything inside that bowling ball is going to rotate with that bowling ball, you see.
But it's going to rotate around the center of mass.
Okay. Now, what I'm going to show you are some animations of what they call orreys, O-R-R-E-Y-S. And these show you how you can understand this Earth in the center, the sun in the center. You can even put Mars in the center, anything you put in the center, and we'll see what it looks like, okay? So what we're going to do is run that animation that we have. Okay, so here's the heliocentric view. Here's the sun, here's Mercury, here's Venus, here's Earth, here's Mars. Okay, now let's do this. We're going to take the sun out of the center and we're going to put the Earth in the center, okay? So watch this. And that's what happens. That's called the Tychonic model, okay? Very simple, isn't it? And what would be happening here is that the universe itself would be going around the Earth on what they call a sidereal rate. That's 23 hours, 56 minutes, 4.1 seconds. The universe goes around the Earth, okay? Okay, so let's just see how this can play out. Let's put Mars in the center. And if you compare this to the heliocentric view, where this every distance you see here, every motion, every position will be exactly the same. The only thing we've done is change centers. Now, I'll show that to you in a second. Okay, so let's stop this side and let's go to the orrery. I mean the geocentric, what's that? Okay, so here we are. Here's the heliocentric. Here's the geocentric. The sun is in the center here. Earth is in the center here. Now notice the sun and Earth are straight up and down there. They're straight up and down. Here's Mercury. same position. Okay, everybody see, stop it for a second. Okay, look, see, everything's exactly the same. Mercury's here, Mercury's here. Mars is here, Mars is here. Earth is here, Earth is here. Venus is here, Venus is here. Just like a clock. Okay, let it go. Watch them all keep the same position. So now you know why they say that either one could be correct. Okay.
So the observable positions, by looking at them, are still going to be the same.
Yeah, either system.
So they picked the one without God.
That's right. They picked the one without God, yeah. That's a good way to put it. Now, God could have made this one too, if He wanted to. And we would still worship God all the same. Okay? If that's what Scripture had told us. All right, so let's go on to that next Ptolemy, Copernicus, Tycho. Yeah, I think it's called geocentric something. Oh, there it is, yeah. Okay, so now here's Ptolemy's model. Ptolemy was an astronomer, Greek astronomer, lived in Egypt around the 2nd century AD, and he created this model, and he had what we called epicycles, okay? The planets would go around epicycles, and he tried to basically make a diagram that worked from what he saw in the sky. Okay, but he wanted to keep Earth in the center. And his model was pretty good, pretty accurate. The only problem is he got Mars or Mercury and Venus in the wrong place, and it messed up his system. Okay. So Galileo came along and said, you know what? Ptolemy's system doesn't show us the phases of Venus, and we can see the phases of Venus from Earth with our telescopes, with our new telescopes. Venus has phases as we look at it, just like the moon has phases. Quarter, full moon, half moon, whatever. Okay? But Ptolemy's model wouldn't allow the phases of Venus because he put Venus in the wrong place. But he was smart enough to say, you know what, I don't know how far away Venus is, so I'm going to make it a variable. And he put 6 variables in his model so that someday in the future, when someone figured out what the true distances were, they could put it back into his model and make it work right. And guess who that was? That was this guy named Tycho. Okay? Let's put Tycho up there. Now, you're going to see a subtle change. You're going to see that ring disappear and another ring appear. And that's basically all that Tycho did. Everything has to be exactly the same, remember. They can't be moving in different directions in each model. They all have to be the same. It's just the way that they do it. And so Tycho fixed Ptolemy's model, and it works. That's the one that Newton said would work. Okay? And Einstein said would work. All right, so let's go to the Copernican model here. See? Everything's exactly the same. If you put the Tychonic and the Copernican side by side, you'd see exactly the same thing. You'd just see different circles. Because the circles represent how they made them move, not where they moved. Okay?
It still looks weird. If we would only focus on our galaxy, the intuitive perspective would be that we are rotating around the center of our galaxy.
Yeah, I understand.
For our solar system, it's intuitive that the sun is in the center.
Well, that's what we've been exposed to for how many years? I mean, we've gotten used to that.
But I can understand that all these scientists go by that because it looks more in order, when the biggest thing, the gravity is in the center and everything goes around it. So as an isolated model, it makes very much sense.
Well, you hit the key word, an isolated model.
Yeah.
It makes a lot of sense.
So
And
I
admitted
can
that
understand
in the
how
program.
they come to this perspective.
Yeah.
I saw, since I was preparing for our interview, I saw a documentary yesterday which said that we must be between two spiral arms of the galaxy, because if we would be in the center of the galaxy, we wouldn't see anything because it's so bright. And if we would be in an arm, also we couldn't see anything because of all the dust. So it must be that we are between two arms somewhere outside of our galaxy. Otherwise, we couldn't even do astronomy because we couldn't see anything.
Yeah. Okay. Yeah. If you look at that isolated system, it works.
So it's probably we are on a spiral arm of the galaxy, because otherwise we couldn't see anything.
Yeah. That I accept that. Yeah.
Can you tell us anything about the concept of ether? What is ether? I don't know how to pronounce it in English. Ether, right?
Ether.
Yeah.
Yeah.
Can you tell us anything
yeah,
about
ether.
this
Ether's-
concept and how it's relevant?
Oh yeah.
to think about it?
Ether plays a very big part in this whole schema of things. Now, in the 1800s, they believed that the space was filled with ether. Okay.
Mm-hmm.
And this made sense to them philosophically or metaphysically as well, because you can't say that there is nothing between the earth and the moon. Because if you say there's nothing between the earth and the moon, nothing doesn't exist. Nothing is the absence of existence, you see. And so that means the earth and the moon should coalesce if there's nothing between them. Okay. So metaphysically, you have to say there's something between the earth and the moon. And the term they gave to that was ether.
So is it like space? Can you say it's like space?
Yeah, we would say ether is space. However you want to define space, ether is it. Okay,
but
and
ether
let's take an
sounds
empty room.
like something which is not a vacuum space, but material. This is what my intuition is when I hear this word.
If this ether is very dense and very small, it can act like a vacuum. And that's why they call it the vacuum of space. Because when you compare that low density with the density you have on Earth, it's like a vacuum. Okay. It's like opening a can of peas and the air rushes in. Same difference, because you have differences in pressure from one side to the other. Okay. But if you take your room, your hotel room there, all right, and you know that it's filled with air, nitrogen, oxygen, carbon dioxide, just air. And if you took all the air out of that, then what's left? You still have the four walls. They're the same distance from each other, but what do you have left? Well, you can't say nothing, okay? Because nothing means there's nothing there that exists, you see. You'd have to say there's still something there. I may not know exactly what it is, but I know something is there.
So basically the privation of something, like physical sin, so to say, huh?
Yeah, you could put it that way, I guess. Okay, so that was their concept, but it was a physical thing. But it was a physical thing they couldn't see or detect, but they knew it was there. Air they couldn't see either, but at least they could detect that it was there, because if I blow, I see the air blow the smoke. Okay, so I know something is there. All right, so that's what they believed in. Now, Michelson and Morley did an experiment in 1987, and they figured that in the direction that the Earth is moving around the sun, which would be westerly, okay, because it's moving around counterclockwise in the heliocentric system. So if we shoot a light beam in the direction we believe the Earth is moving, that light beam is going to meet up with the ether, and it's going to slow it down. Okay, that was what they were working with. And so they did their experiment, shot this light beam toward the direction they thought the Earth was revolving around the sun. And when they got the results back, they could see no difference between the direction that light beam, the speed that light beam was going, supposedly around the earth, around the sun, as opposed to their control light beam, which went the other way and was not going in the direction the earth was going around the sun. They saw no difference between these two light beams. So the conclusion was they didn't know what to conclude, you see, because they had assumed the earth was moving, but this experiment showed them that the earth wasn't moving because the light beam was not being inhibited by the so-called ether, okay? And this just stunned everybody. They were saying, oh my gosh, maybe the earth isn't moving around the sun. That was going around in those days. But the hierarchs of the physics world wouldn't allow that to happen. Hendrik Lorentz was the first scientist to try to explain this in 1892. This was what, 4 years after the experiment was done. And he says, oh, okay, I know what happened. He says, when they did the experiment, the ether put pressure on Michelson's apparatus, his experimental apparatus, and it shrunk the apparatus and gave a false positive for a non-moving earth. Okay.
It sounds.
And I mean, people were laughing just like you're laughing. All right, but that was the explanation. They couldn't come up with anything else. They didn't know how to explain it.
Okay.
And so this, it was called the Lorentz contraction theory. Okay. And so this theory lasted until Einstein came along, and Einstein said, oh, well, you know, we don't like that theory because we always thought about ether. And so how could a frictionless substance put pressure on Michelson's apparatus to make it shrink? Okay. So
Einstein said that.
When? 1905. In his special relativity theory. So he got rid of the ether, okay? Mm-hmm. But he still had to explain how movement could be detected. Because look, this beam was being sent in the direction that the earth was supposedly moving around the sun, and their control beam wasn't going in the direction of the sun, and yet both came back. How do you explain motion? Obviously, then we can't detect the motion. Even though we believe the earth is going around the sun, there's no way we can detect that by using electrical means, okay? You understand that?
Yeah. When they do this experiment, which didn't work out on Earth, if they would do it on Mars, for example, it must work.
Mars, okay.
Yeah, because Mars is moving. So did they ever try to do it on a different planet?
Yes, very, very good. If they did it on the moon or Mars or Venus or Jupiter, what's going to happen? If the geocentric system is right, then they're going to get a positive result from that experiment.
So did they ever try?
That's coincident with the speed of that planet around the sun or the speed of the moon around the earth. They're going to get a positive result that equals that speed, okay? Now, but that you have to get Michelson-Morley equipment up on the moon or Mars, okay? And these are very sensitive experiments. So first of all, they're not going to do it because they don't want to be proved wrong. And even if they did do it, there might be something that goes wrong because these are very sensitive experiments.
I see.
Because you're measuring very small wavelengths of light, okay? Even Michelson had problems with this. In 1881, 6 years earlier, he had tried the experiment, but it more or less failed because there was too much vibration in the laboratory. I mean, people that were walking 100 yards away, you could feel their vibration in the laboratory. Yeah, that's all. So in the second experiment, he put the whole apparatus in a mercury bath. And mercury has this quality of absorbing vibration and not letting it be detected. But even that might have been off a little bit. We don't know. Okay, so that's how sensitive these things are. So back to Einstein now. He says, well, we can't use the ether, but I have no way of explaining the difference in the motion between this direction and that direction. So what are we going to do? Well, he says, well, we're going to have to accept what's his name? Lorentz's formula, that somehow there's a shrinkage, but we're just going to say that it's caused because the light can't get to our eye fast enough because it's limited in speed. And so the front of the object that's moving and the back of the object that's moving are going to give us light reflection in our eye, but the one that's ahead of us is going to have to go slower than the one that's behind, and so it's going to take longer to get to our eye. Okay, that was his explanation. Why?
Okay.
Well, because the speed of light is constant. Can't change. So if it has to cover more distance, it's going to take a longer time to get to us. And that's where time dilation comes in. Because if you're going to say that that light beam that's in the front, it's going to take a longer time to get to my eye than this light beam, then that means that this light beam has to travel with more time than this one does. And so now I dilate the time. Okay? So, and that's what the special theory of relativity is, basically, is length contraction and time dilation. All right?
Okay.
And then if I'm going to have to add mass to the object, because if the object is getting from point A to point B and it doesn't get there in the right time, well, then it's going to have more. Then the mass is going to be compressed, and that means you're going to have more mass per unit volume by the time it gets to point B. And so now you have to have mass increase, and that's what the special theory is: length contraction, time dilation, and mass increase, all to try to explain this positive result of Michelson's experiment.
So I'm really not an expert in physics, but I've heard that for the general theory of relativity, everything was changed again. Einstein introduced ether again. And so,
yes,
true. Can you elaborate on that?
Yeah, I mean, it's absolutely remarkable that science can live with its contradiction and not have it affect everything that they think. But the special theory is totally opposite the general theory, because the general theory allows first gravity and inertial forces, like I said at the beginning, okay? And if it does, then it has to make light speed non-constant, okay? And it has to make the speed of material objects infinite. And guess what? Einstein took back the ether. The very ether that he got rid of in the special theory, he takes back with the general theory, because he says light needs a medium.
Okay.
In the special theory, he says light doesn't need a medium. It can make its own medium. In the general theory, he takes the ether back because he says light needs a medium. Okay.
So what is the state of science? What do people say? Do we have an ether or not?
That's a very debatable subject, because there's a lot of books coming up now and say, look, we need to get the ether back into science and get rid of this idea that Einstein did away with the ether. He didn't. He's the one that took it back. So if you want to go follow Einstein, put the ether back in science, and it'll explain a lot of things.
Okay. So let's go back from the science part again to the theological part. Did the church actually ever define geocentrism as a dogma? And if yes, is it infallible?
Okay. So this is where the language or the discussion usually ends up with the church is, was it infallible? Now, keep in mind that the definition of papal fallibility wasn't given to the church until 250 years later in 1870, as opposed to the Galileo issue, which was occurring in around 1616, 1633. So the issue of infallibility is that argument is kind of anachronistic, because you're taking a future decision of the church and you're trying to put it back into the past history. Okay. In other words,
maybe the Pope has fulfilled the criteria of Vatican I in the past, and then maybe we can use it backwards.
Yeah, retrospectively, we can look in the past and say if they fulfill the criteria. And if you do that, they fulfilled all the criteria.
Okay.
Paul V and Urban VIII. Okay.
Okay.
And I wrote a book about that. Okay. So you can get all the details of it. Now, but I'm just a layman. I'm not the church that has the authority to declare that what Paul V and Urban VIII said was infallible. And this is where the problem of the church comes in. You know, there might be a lot of infallible doctrines back there in the past, but the church has not given us a list of which doctrines are infallible. Okay? And probably for good reason, because somebody's going to say, well, I'm not going to obey the church unless it's infallible, you know? And that means all the other doctrines the church teaches, you're just going to avoid. So the church doesn't want to go there for a reason. They want to make it like it should be that, you know, whatever the church says, you should obey. Infallible or fallible, and you should obey it because that's what the church said, you see.
Yeah.
So
but at
there's
least
a method to their madness.
If it's not infallible, all the liberals, they have the excuse that they can say, oh, it's not infallible, so maybe the church was wrong anyway. So that's why I'm asking.
Okay, I said that they have no right to make that decision because they're not the authorities. So this is what happens with people, is they think they have the right to make the judgment of whether the Galileo issue was infallible or not. They don't. Only the church does.
But we don't either, like you just admitted, so it's a problem. So we have to fight against them.
It's a problem.
Yeah.
It's a problem, except for Lumen Gentium 25 says that even if the church doesn't teach it on an infallible level, we're still required to give mental assent to it.
Yeah.
And believe that it's true, you see. So the church is taking care of that problem. In other words, just because it's not declared infallible doesn't mean you can avoid it or reject it. You're supposed to give mental assent to it.
So did the church ever changed, or did the church ever say something contrary to geocentrism in the last centuries?
No, not at all. There's never been one official statement from the Catholic Church that either rejects or rescinds whatever was said about Galileo in 1616 and 1633.
Because I've heard something that John Paul II said sorry or something regarding Galileo. I'm not so long Catholic already, so that I don't know all the details yet, but that's what I picked up.
But it wasn't an official teaching of the church. That's the issue. It was an address to the Pontifical Academy of Science. That's all it was. So it's not an official teaching of the church. So he may have leaned that way in his own personal thoughts, but he didn't make the church doctrine.
He never declared anything.
That's right. Now, what's interesting is that Cardinal Ratzinger, another German, who was, he was the prefect for the Congregation for the Doctrine of the Faith in 1990. He went to Parma, Italy, and gave a speech on Galileo, okay? And he's saying the same thing that I'm telling you today. He's saying that because of the nature of relativity, that we can now say safely that the earth can indeed be still and the sun and the stars revolve around it. He said that in his speech. And you know what they did to him? They kicked him out of Parma, Italy, and they said, never come back again.
Okay. So why did he, when he has this knowledge, he surely knows about the relevance. So why didn't he ever declare anything while he was Pope?
Good question. He also resigned as Pope. So maybe he wasn't in for the battle. That's, you know, maybe he just had enough.
Okay. Yeah, I'm not married yet, so I promise if it happens that I go in the priesthood and become Pope, I will definitely define it.
All right. Anything else?
When I was Protestant, I always made the joke that if I ever become Pope, I get rid of all the Marian dogmas and teachings and say that sola scriptura is infallible. But once I read your book about sola scriptura, I knew, okay, that's it.
Yeah, that's it. Yeah, there you go. Well, once you
Yep.
become Pope, I want you to reinsert the geocentric doctrine back into Catholic teaching.
Yeah. So for the record, if I ever become Pope, that will be one of my first acts.
Okay, great.
So
All right.
talk about
What
another
name would you take if you were Pope? What name would you take if you were Pope? Pope what?
Of course, Pius the 13th.
Pius the
according-
13th.
like,
Wow.
You know this movie, this TV series, which came out like I think a few years
I've
ago.
seen that.
So this would be my inspiration.
Yeah. Okay.
So let's talk about another German person, this time a woman, Hildegard von Bingen. It's very close to my hometown, Frankfurt, where she lived.
Oh.
I have heard that she had some visions of geocentrism. Do you know anything about this? Can you
Oh, yeah.
tell us?
Yeah, I have a book on her. I wrote a book about her. She was from the 1100s, and she was well gifted. She was very intelligent to begin with. And then she had some visions. And in these visions, one of the visions gave her the map of the universe, basically. And it was geocentric. Okay. And she had the same Tychonic model that Tycho de Brahe invented, what? How many years later? That would be 500 years later that we have this Tychonic model, and that's the same model that Hildegard's using in her 1100 book. Okay, so this woman must have known something. Somebody's given her some information, okay? And she's got this very elaborate, she talks about the ether, and she talks about the layers of the universe and all kinds of interesting things. And yeah, I've been selling that book for many years because she was one of the first ones I went to. So I figured, wow, this is true. Where can I find some support in Catholic history for this from a scientific point of view? And she was a scientist way ahead of her time. She's talking about concepts that they're just beginning to discover now in physics and chemistry and other things.
So
and
was she actually a scientist or a mystic?
Well, not a mystic. No, she wasn't really a mystic. She was more of a scientist. And that's what made her stood out above everybody, because she was basing her theories on how things in nature relate to each other. And yeah, way ahead of her time, as far as that's concerned. Way ahead of Mendel and Leeuwenhoek and all these other guys that came along in the 1700s. So she must have got some vision somewhere. Because I can't imagine a woman of this middle age, know-nothings, basically, coming up with these theories. I just can't imagine that she got this other than from a vision. So at any rate, when I wrote about Hildegard, I sent a copy of that book to Pope Benedict when he was Pope, Joseph Ratzinger. And the next thing I know, a couple years later, Hildegard is made a doctor of the church, and she's canonized as a saint in the same year by Pope Benedict. Okay, now that is remarkable, because here's a saint that's been, or a woman whose fantastic faith and theories came from 1100 years ago, and she's been on the shelf all that time until 20-something, and Benedict says, okay, we're going to make her a doctor and a saint at the same time. Okay, where did that come from? Well, I sent him my book. I never got a reply from him, but I did send him the book. And maybe that had something to do with it. I don't know, because I write all about Hildegard in that book.
Yeah, I think Benedict, or early times Ratzinger, had a lot of insight, even what is according to the topic of evolution, because I know that he founded a school or something together with Alma von Stockhausen. They were founding some school, or had, I don't know if they founded together, but they were connected. Alma von Stockhausen died a few days ago, unfortunately, and they, in this school, they were, or in this, I don't know how to call it, seminary or whatever it is, I don't know. In this institution, they were researching stuff like Luther, Hegel, evolution, and all this stuff. So they are very conservative. So I know that Ratzinger had some connection to all of that. So I think he had a lot of insight even to the evolution topic during his life. So yeah, maybe he knows a lot more than we think. So it's very sad that he didn't do anything when he was in office of Pope.
Yeah, I went to Italy back in 2002 with a group of people, and we got in to see Cardinal Ratzinger at that time. And we talked to him about evolution. And he came back and said, well, I just can't believe that, you know, all this oil that we have didn't come from the fossils that have been buried over millions of years. I mean, that was one of the excuses he gave to believe in evolution. And so we came back with the theory that is proposed by Guy Berthaud, and he's presented papers to the French Academy of Sciences and the Russian Academy of Sciences on this theory that the geologic column that has all the layers can be made in a matter of weeks or months, depending on the water flow and the weight of the particles that are in the flow. And they've done experiments, they call flume experiments, where they've proved this. And he's not the only one. There's about probably half a dozen scientists all around the world who've done the same thing. And so basically they've shown that the geologic column does not take millions of years. It can happen in a matter of months, as long as you have the right water flow. And of course that water flow all goes back to the Noachic flood, okay? And so we presented that idea to him and said he would think about it, and then we left. That was it, okay? So I don't know where he went from there, but that was back in 2002. So who knows? He's a very troubled man right now. He's very troubled because, as he called them, the wolves in the church were after him. And they put so much pressure on him that he just couldn't take it anymore. And I think that's one of the reasons why he left. He just couldn't take the pressure anymore. Yeah. So, you know, it's really bad. He was dealing with that homosexual pedophile scandal. He was dealing with a lot of other issues that were coming up, and, you know, anyway.
Yeah, I remember.
That's all I have to offer on him.
I remember when he was elected as Pope, our biggest newspaper in Germany headlined, "We are Pope." It's like we are a World Cup winner in soccer, you know. So they used this phrase, "We are the winner," and said, "We are Pope," you know. It was quite a funny thing.
Yeah. Yeah, soccer is really big over there, isn't it?
Yeah. So every time the German team wins, the whole nation wins. So when we gave the Pope, the whole nation was Pope.
See, that's the trouble with Germans. Everything they do that's good goes to their head.
Yeah. So do you actually know any German material? Of course, I will link your material down in the video description, but do you know any German material, or in general, do you know any other material about this geocentric topic is influential, or which you could recommend?
Yeah, we're scattered. We're scattered pretty much. It's usually individuals in various countries. There's not a group of geocentrists in one country, so to speak. For example, in Croatia, How far are you from Croatia?
Right now, I'm in Bali in Indonesia, but Croatia is right around the corner in Germany. Yeah.
So we have a scientist in Croatia,
Okay.
and his name is Luka, and he's a nuclear physicist. He's got a PhD in nuclear physics. So he's a scientist and knows his stuff. I converted him to geocentrism, okay?
Nice.
And then he wrote a paper on geocentrism and he didn't use the word geocentrism, okay?
Okay.
But he wrote a paper which is geocentric, and he submitted it to the European Journal of Physics, and they accepted it. This is in 2013, okay? And then then he wanted to write another article and submitted it, and they didn't accept it. And the reason why is because they got wind that he was trying to promote geocentrism. So there you have it. Here you have a PhD in nuclear physics writing a paper that all scientists should look at and read. And as soon as they found out geocentrism, oh, can't have that. Can't have that.
It's the same game like with the evolution topic.
Yep, same game.
Yeah.
That's why the Pontifical Academy of Science won't allow any creationists in the Pontifical Academy of Sciences meetings every year in Italy.
Wow.
They haven't allowed the creationists in for the last 30 years. And, you know, so they won't give us a voice.
So who's that guy that converted you where you were surfing on his website?
His name is Dr. Gerhardus Bouw. He's a Dutch Christian, Protestant Christian.
Okay.
And he got into it many years ago. And he is a disciple of Vanderkamp, Walter Vanderkamp, who was a Christian scientist. This is back in the 70s and 80s, in the 20th century.
Okay. So how come that those Protestants were first?
Because they're the ones following Henry Morris. You know, Henry Morris, back in the 1960s, he wrote the Genesis flood. This was the first scientific endeavor of Christians, evangelicals in the 20th century, basically. And he started the ball rolling. And after him, he had a whole flood of Christian scientists coming along, and Vanderkamp was one of those.
Okay. So are there any other materials you can recommend?
Well, you can go to Gerhardus Bouw's website. It's called geocentricity.com.
Okay.
You can look him up. My website is journeytothecenteroftheuniverse.com. I have all my books and materials there. So the principal movie that we did 7 years ago, we had it in U.S. theaters here in about in a 6-month period. We had it in 15 U.S. theaters. That's also available on our website, journeytothecenteroftheuniverse.com.
It was available on YouTube last year when I came into this topic. Now it's gone.
Yeah, well, see, those are piracies. The people copy the movie and put it on YouTube illegally. And we've lost tons of money.
Is there a German version or German subtitle?
There is a German subtitle, yeah. And
okay.
The movie Journey to the Center of the Universe also has German subtitles.
Maybe I can speak it in one day, and then we can also publish it in German.
Yeah. I have Russian, I have French, Italian, Spanish, English, German, and Portuguese in that second film, sequel, Journey to the Center of the Universe. Now, also for you, you can go to YouTube and see my new movie called Einstein, the Closet Geocentrist.
Oh, okay.
Yeah, Einstein, the Closet Geocentrist. And that's a 2.5-hour movie I put free on YouTube.
Nice. I will link everything down below in the video description. And then the people can check out everything on their own. So I thank you, Robert, for your time. And I will help you to promote it in the German-speaking world.
Okay, great. I'll see if I can get a German edition of my newest book, GEOCENTRISM for Dumpskis.
This would be great.
Yeah. All right, we'll be in touch. Thank you so much.